This video will have a look at multiplying matrices using the product matrix method when we've got powers of a square matrix to multiply. So the steps to complete a product multiplication matrix. Step 1 will be to confirm that a product matrix does exist. Now a product matrix will exist when we have the same number of columns in the first matrix and the same number of rows in the second matrix. So if you're not sure on how to check for that, go back and have a look at the video introducing a product matrix, and it will explain how to test to see whether a product matrix exists. Step 2 will be to multiply the elements of each row in the first matrix. So we're looking at each row in the first matrix and by the elements of each column in the second matrix. So that will become important when we go ahead and complete our product multiplication matrix. And step 3 will be to add the products of each element together to form the product matrix. So let's have a look at how we can apply this to our powers of a square matrices. So in the example, we've got matrix A, which consists of 2 rows and 2 columns, and we want to calculate the value of A to the power of 3. Now, A to the power of 3 is going to be the same as A times A times A. So when we're doing that with matrix A, it will look like this. So it will be matrix A times by matrix A times by matrix A. So to be able to complete that calculation, we can only multiply 2 matrices together at a time. So what we would do is we'll calculate the first 2 matrices and multiply them together. Then once we have our answer for that multiplication, we would then multiply it by the third matrix to get our solution to A to the power of 3. So let's have a look at multiplying the first 2 matrices together. So because I am multiplying 2 matrices that are the same together, there is going to be a product matrix. So to complete the product matrix, I'm going to take the first column from my first matrix. So that is going to be 3 and 5, and multiplied by the first row of my second matrix, which is 3 and 5. Then take the second column of my first matrix, so 5 and 1, and multiplied by the second row of my second matrix, so that it will be 5 and 1. So then going ahead and completing each of those multiplications. So 3 times 3 is 9, 3 times 5 is 15, 5 times 3 is 15, 5 times 5 is 25. Then I've got 5 times 5 is 25, 5 times 1 is 5, 1 times 5 is 5, 1 times 1 is 1. And then go ahead and add each corresponding element together. So 9 plus 25 is equal to 34. 15 plus 5 is equal to 20. 15 plus 5 is equal to 20. 25 plus 1 is equal to 26. So that's the first part of my calculation. I've multiplied the first 2 matrices together. So now I'm going to take that and multiply it by the third matrix. So this time it's going to be multiplying these 2 matrices together to get my final answer. So I'm going to do that by following the same process as I used for my first multiplication calculation. So to complete the calculation, I'm going to take the first column of my first matrix, so 34 and 20. I'm going to multiply it by the first row of my second matrix, so 3 and 5. Then I'm going to take the second column from the first matrix, so 20 and 26, and multiply it by the second row of my second matrix, 5 and 1. So now that I've got those numbers set up, I can go ahead and complete each of the multiplications. So 34 times 3 is equal to 102. 34 times 5 is equal to 170. 20 times 3 is equal to 60. 20 times 5 is equal to 100. So moving on to the second table, 20 times 5 is equal to 100. 20 times 1 is equal to 20. 26 times 5 is 130, and 26 times 1 is 26. So now that I've completed each of the multiplications, I can go ahead and add each of the corresponding locations. So 102 plus 100 is going to be 202. 170 plus 20 is going to be 190. 60 plus 130 is equal to 190, and 100 plus 126 is equal to 126. So now I've got my final matrix that will be the answer to the original question. So matrix A to the power of 3 is equal to 202, 190, 190, and 126. So that is an example of how we can use the product matrix multiplication method to be able to calculate the square of a matrix.